the show function, right? Now, if you pass the data source inside the show function, it will output you the map. So, like this is the
Okay,
remote
so hello everyone. Good evening.
right. If
So can
I
you hear me?
to this,
Yes, sir.
Okay. Just we are waiting some 1 or 2 minutes for joining all of the other participants. Then we'll. Okay, so hello everyone. Welcome to the 7 days online training program on Google Earth Engine. So basically, today is our fourth number of days. We already covered our first day, second day, and third day, and today is our fourth number of class. Okay, so basically today's class we also try to discuss about some advanced remote sensing technique so that we can easily work with that. Okay, so let's go. So just I simply share my screen and then try to start. And after completing this tutor for today's session, we also try to discuss about our problem solving. Okay, for problem solving for the 1 hour, we also try to discuss about the different types of problem and also try to solve all of those problems. Okay, so let's go. So let's go. Okay, so basically today is our fourth number of days, and mainly today we'll try to discuss about that how to remove from the cloud from satellite imagery. So okay, so another person will join. So today we will try to discuss about that how we can easily remove the cloud from the satellite images and also get the very good quality satellite image. Then how to visualize the DEM data, and using this DEM data, how we can easily create the hillshade map, salt map, and aspect map using the Google Earth Engine platform. And we also try to discuss about the land surface temperature monitoring land surface temperature monitoring from MODIS satellite imagery. And previous class we also try to discuss about that how we can easily create land surface temperature using that Landsat imagery. And today's class we will try to discuss about the MODIS. Okay. Then how to calculate for average, maximum, minimum, NDVI for any specific region. It's not only for the NDVI. So using this process, you can easily calculate it, any types of pixel value. What is the average pixel value? What is the minimum pixel value? What is the maximum pixel value? For anything, it can be NDVI, NDWI, or EVI, anything you can easily calculate. So let's go. So first of all, how to remove the cloud from satellite imagery. Mainly Landsat and Sentinel, both of image, we are easily remove the cloud and also remove the cloud shadow. From that, we can easily remove all of the things. We can get the very clear satellite image. And previous class, we also try to discuss about the one code about that LST. In this part, we are also adding a part about that cloud cover, removing the cloud cover. Okay, so we are also use the same code today also for the Landsat. And mainly today I also show you that for the Sentinel imagery, how can easily remove the cloud from the Sentinel imagery. Okay, so let's go about that. So here you can see the first image. This image we can find out some cloud pixel value. Also we can get some haze. This is the white pixel value, cloud pixel we can find out in here. And when I apply this cloud marks band function, then all of those cloud will be removed, and we also get the very clear satellite images. So let's go practically. We try to discuss about that, how we can easily do that. So for that, I simply open a new code editor. Okay, so can you hear me properly? Hello.
Yes.
Okay, thank you. Okay, so now I just simply work with in code editor. I open that. Suppose I want to work with for the Sentinel 2 satellite imagery. Just I simply search here. Here I can get all of those image collection. Suppose I want to work with this multispectral instrument level 1C, and you can see the band about that cloud marks band function. You can see this is a cloud marks function, cloud marks band. Okay, so mainly this cloud marks band help you to remove all of those cloudy pixel from your satellite images, and using this band we can easily remove our unnecessary cloud. Okay, cirrus cloud, opaque cloud, this type of cloud we can easily remove using this band. Okay, so I just simply import that. First of all, import this image collection, and first of all I want to try to display the image. Okay, then try to remove this all of those cloud from here. Yes, you have any question? Hello, any question? Okay, so do you have any question? Okay, okay, I cannot hear you, Muhammad Jairuddin. I cannot hear you, but you raise your hand. Okay, so now I can see here we can simply import our image collection in here. Okay, so it will be default variable name is the image collection. So just I simply change it and put the name, suppose Sentinel 2. Okay, so now it is stored in this image collection. Okay, so can you hear me? Hello.
Yes.
Okay, but
I can hear you, sir.
I think you're some problem, Muhammad Joir. You have some problem for your speaker, because other participant also showing hear my sound. Okay, so there is a no problem about that. You can check it for your own system. Okay, so okay, so in this time here you can see I simply imported my image collection and it is stored in here Sentinel-2. Okay, so now I display the image. So suppose I need this image for my region of interest, Dhaka city. I just simply import also my region of interest as a Dhaka city and put this name, suppose ROI. Okay, and now take a variable. Suppose I put the variable name is that image, and in this variable I just simply call my whole image collection Sentinel-2. It use here the filter bounds function, filter bounds with ROI. Filter bounds with ROI, and then I suppose I need this image for the specific time period. I simply use here the filter date function and put the specific time period such as year of 2020 1st January from year of 2020 December, suppose 31. Okay, after that I simply use here the filter metadata and put here this image properties name is that cloud pixel percentage. So just I simply copy and paste here and put the operator less than and set the value for 1. Okay, so now all of those images I just create the median composite, median, and then I simply use here the clip with my shape file is that ROI. Okay, so now display the result about that. I simply add this and then also focus the center of the shape file. So use here the map dot center object is that ROI and put here 10 and click to the run. Okay, I also just use here this run combination. So now I just simply put here red, green and blue. Start 98% and then apply. So now we can get this image, but this image is not mass cloud. You can see this image is not so much cloud. Okay, but I need a cloudy image. Okay, so that's why in this time I simply take here the suppose 90% cloud and then check again about this image what the condition when I put the 90% cloud. B4, B2, 98%, apply. Okay, it's also not mass cloud. You can get some small cloud pixel value in here. We need the cloudy pixels. So for that, suppose I want to put here the year of 2016. Suppose 2016. So now I try to again about this time period or the condition. Basically for the previous time satellite images, we can got cloudy pixel. Lot of time you can check the Landsat 7, Landsat 5, Landsat 4. This type of satellites is not very clear. Okay, they are not, their satellite information system is not acquired to able to the cloud free. Okay, so that's why we can get a lot of cloud for the previous satellite imagery. But in the present time, for that different, suppose 2023 or 2020, okay, we can get the very clear satellite image. Okay, so that's why I simply get the previous past year and then check about that. Suppose B3 true color composite 98%, and now check about the result. Okay, you can see this time we can get the some cloudy pixel. You can see this is the cloud. You can see this is a cloud. Okay, so now I just remove this type of cloud. You can see this is a cloud pixel. Okay, also white color pixel we can get in here. Okay, so you can see I can get some cloudy white pixel value. Okay, so this cloud pixel value we can easily remove in Google Earth Engine platform and also get this clear satellite images. So now I talk about that what is the process for the removing the cloud. Okay, so I can get the cloudy image now for this time. So now anyhow I just remove this type of cloud and also make the clear satellite image. Okay, so for that what can I do? So first of all, I need every satellite image for the Landsat or Sentinel has a band. This band name is that US cloud marks band. Okay, you can see this band name is that cloud marks. Okay, and this band in this time for Sentinel it's called the QA60. For the Landsat it's called the pixel QA band or QA pixel or pixel QA. This type of name for the Landsat. But Sentinel 2 we can get the name as that QA60. Totally unused. Also you can see bit 10. Bit 10 has a two signal 0 and 1. Okay, 0 means that no opaque cloud. Also you can see 1 means that opaque cloud is present. Also bit 11 it's the cirrus cloud. Bit 11 has from bit 10 I select signal 0. Okay, so for that what can I do? I make a function to clouds. You can use any name, there is no problem. After that simply use a function keyword. Okay, and put this keyword name suppose img. Okay, for then use the curly bracket. In this curly bracket I just write my argument. My first argument is that I need to select the image band QA60. So take a variable name suppose QA and call this element name image. From here select the band of QA60. Okay, so I select my band, requirement band I select. But when you are work with for the Landsat image, then it will be pixel QA or QA pixel. Okay, but in this time I work with the Sentinel, so that's why I put here the QA60. And then I need to select the bit. Okay, so you can see here for this image has a total 3 bit. You can see this image has a total 3 bit. Bit 0 to 9, bit 10, bit 11. I work only for the bit 10 and bit 11. Okay, so for that what can I do? I just take a variable suppose cloud bit marks and use at the 1 less than 10. Okay, this is the 1 bit 10. I select the 1 bit number 10 and take the another suppose cirrus bit marks and set here 1 less than 11. So this is the system or this is syntax for selecting the bit. So I select the bit 10 and also select the bit 11. Okay, so now bit 10 is stored in this variable and bit 11 stored in this variable. Okay, so now what can I do? From bit 10 I set equal to 0, and also from bit 11 I set equal to 0, because you can see it's showing the result about that bit 10 0 means that there is the no cloud, and bit 11 means that there is the no cirrus cloud. Okay, 0 means that no cloud. Okay, so I need to select from bit 10 I select the 0, and also from bit 11 just select the 0. Okay, so let's go. So for that, what can I do? I take a variable, suppose marks, and then I simply call this QA, and this QA mainly it's the image band. Okay, this image band has a bit 10 and 11. I simply use a function in here, bit wise and, so it's the lowercase bit wise and. So mainly this function connecting the bit with the band. Okay, so just I simply call this cloud bit marks, simply copy and paste here, and use here equal to 0. Okay, so what can I do? I just simply take the QA, it stored the image band, cloud marks band, and this cloud marks band I want to add with my bit number. So first of all, bit 10 stored in this variable, so I simply call this and set equal to 0. Okay, and do for the same thing. So I use here the AND function. After that, simply put here the again, call the QA, and then use here the bit wise and call this variable name cirrus bit marks. Simply copy and paste, and use at the set equal to 0. Okay, so now it's done. Okay, so now my condition fill up. So my condition is that I just select the band QA60, then select the all of those bit. Okay, then all of those bit I connect with the band and set equal to 0. Okay, so I also do that. So now I need to update. Okay, so using this information which I put in here, using this information I need to update this image. So what can I do? I just simply use a function in here, return function, return this image, use at the update marks. Okay, update marks with, I simply copy this characteristic, because all of those things stored in variable. I want to update my image according to this condition, and all of those condition is stored in this variable name marks. Okay, so now this is my function I create. Basically mainly this function removing the cloud, this type of cloud, and also this type of haze will be removed from your satellite images, and we can get this clear satellite image. Okay, so now my function is ready. When I connect this function with my image collection, then it will be work and remove this type of cloud. Okay, so now how I can connect? So for that I also try to make the another layer. Okay, so just I simply copy the same code, then we can easily identify about the cloudy image and clear image. Okay, just I simply paste in here. Okay, for connecting, suppose I put here the in here, suppose image 2, and then I want to add here this. So for that I simply use a function, map function, and call this function variable name. Simply copy and paste here. So now this function which I created in here, it's added with my image collection. Okay, so now we check about the result. Click to the run. Okay. Okay, so just a minute. In this time, it will be just look like that. Bitwise and use at the equal set to 0. Okay, and at bitwise and it also just set equal to now check. Okay, so now it worked. I take the another name, suppose cloud C. So we can get in this time two layer in here. One layer is represented the cloud, and when I want to use here the cloud marks function, then it will be remove all of those unnecessary white pixel value and get the clear satellite images. So you can see, I also zoom in. Okay, so now you can see here we can get this image. So first of all, it's a cloudy image. A lot of cloud pixel value I can find out in here, but when I apply this cloud marks function, you can see everything is clear. Okay, so this is the difference about that. You can see first there is a totally clear image, but you can see this type of cloud will be removed when I want to apply the cloud marks band function. On also you can see haze, this type of haze. Okay, we can get this. So that's why in this time it look like that. But when I apply this cloud marks band function, this type of haze will be removed and we can get the very clear satellite images. Also you can see for this part. Okay, in this time I simply open that cloud free image. So now this type of cloud will change the something about that band name. So for band name, and also change here the bit number. Suppose cloud shadow. Okay, I'll also show you how can you remove the cloud. So you also try to remove the cloud from the Landsat. Suppose Landsat 9, you try to use the Landsat 9. We can get the band. You can see QA pixel. Okay, so basically this is the quality pixel of the image. So QA pixel, and also you can see bit marks for QA pixel. So you can see there's a lot of bit about that. You can see cloud. Okay, bit 3 less than 3, and you need to work with the, suppose you can see 0 region. So you want to remove the snow. So for that you can also use the bit 5. Okay, so this type of bit we are easily using, and all of those bit we can simply represent. Suppose you want to work with for the bit 3, so simply use here the bit 3. Okay, then it will be work for the bit 3. Okay, so in this time we work for the bit 10, so put at the bit 10 for the sentinel. Okay, but when you are working with for the Landsat, just change all of those things. Not only for that, if you want you can also add here the more bit. So then you are also use here the another AND function, and also put this set equal to. Any question, anyone, for removing the cloud and haze from the satellite images? Any question or any doubt?
We can remove.
Yeah, please.
We can remove. We can remove the cloud on specific single images also.
Yeah, same process. Suppose you want to select for the specific image and then work with that. There is no problem. But in this time I create the median composite and work with that. Okay, but we can easily apply also single image or single date image, also apply the same process, getting the clear satellite images. Okay, so anyone any question about that? Using the Moody's satellite image area, how you can easily make the, and also make the time series chart about that. And also you can see this time series chart, we are also get the some line break. Okay, so this type of line break we can easily remove and also get the continuously time series chart. You can see it also break in here, it also break in here. Okay, so this type of result, how we can easily get that. So I'll also try to discuss about that and also get the very beautiful chart about that. In this time we can get the new code editor. Okay, so just open a new code editor and try to discuss about that. So in this time I want to work with for the MODIS LST or land surface temperature, and also show you that how can easily create the time series chart, and this time series chart how we can easily remove the line break. Okay, because in Google Earth Engine platform, not only for the, and also show you that how you can easily create the time series chart about that LST. So first of all I need the data set. So just I simply click on the MODIS. So now I can get the access the MODIS data set, and I 8 day. Okay, this data set provide you the every 8 days time period data. Okay, so every 8 days average, and this data set provide you the daily, what is the condition for the daily LST, suppose 1st January, 2nd January. So I want to show you one. So suppose I want to work with for that daily data set, how can I easily make the daily time series data. So click on here. So now I can get about the all of this information, and also you can see this data set has a new also they are provide the new data set about that. This has been superset by this. So I simply click on here. So now I can get the update data set. You can see here of 2023 06 15. So this is the update data set about this. Okay, 15 June, and today is that 19 June. Okay, so from this data set you can easily access about this 15 June. This is the latest. Okay, so now I want to work with this data set. So first of all I simply copy that image snippet, snippet and paste here. Okay, and give a variable name. Suppose I put the variable name is a MODIS. Okay, and also you can see this MODIS has already a scale. Okay, so when you can get the scale this type of value, you must be multiply all of those images with this scale or get the proper result. Okay, or make the reprojected your scale value. Okay, that's why then we can get the proper pixel value result, otherwise this result is not proper. Okay, so mainly select function. So select, okay, and paste here. Okay, after that what can I do? Suppose I need the time series chart for over a period of time, suppose year of 2023 1st January from year of 2023 year of 2023, suppose 06 June, suppose 14. Okay, so this is my time period, simply import that. Okay, so now I check how many images are available for that. So I simply print the MODIS LST and use the function size function. So now let's check how many images are available for that. I can get between this time period 163 images is available, and now I want to make the time series chart about that. So this is my image collection. Okay, and this image collection is not reprojected. Okay, so let's go, we try to make the time series chart about that. What the result we can got first of the eye to check. So for that, for the time series chart we are using a function UI chart.image.series. Okay, so here I can get this type of information. You can see image collection, region, reducer, scale, X property. So all of those my argument. Okay, when I fill up all of those argument, then it will be able to create the time series chart directly. But I put here the result as a keyword and key value. So image collection is a keyword. Okay, so how many images is available for the region of Bangladesh? So just I simply Bangladesh country boundary. Okay, so I import that Bangladesh country boundary and then put here the name, suppose ROI. Okay, you can use any name, there is no problem. After that, okay, after that I simply use the region is that this time when I for 1 day, when I put here the mean, then it's showing the result about the minimum result. Okay, LST scale is the resolution in this time resolution is that 1000 meter. X property, so I simply put out the X property is that system time start. All of those things I just store it in a variable. Suppose put the variable name is the chart. Okay, so now just I print the chart, then the chart will be appearing. Okay, so let's go. So simply print that the chart. So now let's check about the result. Basically, this generating chart is mainly depend on your area. When you want to work with for the big region, then it takes some time to producing this chart. And when you want to work with for the small region, then we can immediately we can get the result. Okay, so we are waiting some time and check what the chart we can got. It's generating.
Can I ask a question?
Yeah, please.
So the chart will be generated like the line graph.
Yes.
Oh yes. So is it possible to make the
Bar graph.
bar graph or other types of?
Yeah, it also possible. Yeah. So in this time, okay, I'll also show you that how can I do that for creating the bar graph chart, all of that. So basically in Google Earth Engine platform, default is that showing that line graph chart. But if you want, you can also show the result about that bar graph. It also possible. Okay, I also show you that about that. So in this time, the chart is the look like that. We can get that result about that. You can see in the temperature is the increasing day by day increasing. Okay, for the year of 2023 from January to present time for this 15 June 2023. Okay, so now in this time, what's the problem you can face in here? This problem is that it's showing the result. You can see 15,134. Okay, so it's showing this type of result because it's not reprojected. Okay, it's not the reprojected, so that's why we can get the result look like that. When I reprojected that, then we can get the better result or accurate result. Suppose normal result we shall show. Okay, in this time this result is totally not good. Okay, so in this time I need to reproject the scale. So for the reprojecting, what can I do? 163 image I need to multiply with my scale factor 0.02. Okay, so for that what can I do? I just simply use the same. Suppose if you want, you can also take the another variable and do that. In this time I just use the same variable, and in this variable I use a function, map function. Okay, and then call the function keyword and put here the image element image, and then put here the curly bracket. In this curly bracket I just put my argument. My argument is that all of those images, 163 images, which already stored in this variable, this image I need to multiply with this scale factor. Okay, so for that I use a function, return function, return this element, multiply with what's the value, multiply with I check the value again. You can see 0.02. so this is my scale factor. I simply copy that and then paste here. Okay, so now what? Okay, in this time it will be reprojected. Okay, and I also want to change the unit. Okay, the default it's showing as a Kelvin. Okay, default time it's showing as a Kelvin, but I can simply remove this Kelvin to degree Celsius. I can simply convert the Kelvin to degree Celsius. So for that, what is the equation? Just you can simply subtract the value 273.15. Okay, just I simply subtract from here 273.15. Okay, So when I subtract this value from the Kelvin, then it show the result as a degree Celsius. Okay, so then I simply apply all of those things with all of those images. So use the copy properties function, and all previous class I also tried to discuss about that all of those things. Okay, when I talk about the modis and dvi, so use the copy properties, copy make it the upper, yeah, copy properties, and these copy properties come from this image, and then it apply from the system time start which I put in my system, and also apply up to system time end. Okay, so just I simply copy these properties and apply all of those images which are available. Okay, it takes some time because it's a big region, whole country boundary of Bangladesh. Okay, so it's depend on your area. In this time look like that, and in this time you can get make also more money menu, such as suppose put here this set option function, set options, and put here the all of those things. So first of all put here suppose title, I put the title suppose LST time series chart, you can put any time any title, and then put here the suppose x level or v axis or vertical axis. Vertical is the y level. Y level I put the name such as y level. Title is that I simply put the title. Suppose is represented the LST in degrees Celsius. Okay, and then put here the another thing is that a horizontal axis of this information.